Welcome to the Wind Sustainability Series. This is episode number 8, Holding an Approach. In this video, we're going to talk about what you can do as a pilot to reduce fuel consumption and CO2 emissions during the holding and the approach phases. Firstly, it may be obvious, but the flight crew should avoid holding unless this is requested by the ATC. Now, if the holding cannot be avoided, there are two variables that the flight crew can use for fuel saving and CO2 reductions: the flap configuration and the speed. First, let us take a look at the flap configuration. As for the cruise phase, the aircraft should be kept in an aerodynamically clean configuration and then deploy landing gear and flaps only at the required moment. Extending the slats, flaps or landing gear too early increases the drag and consequently the fuel consumption and CO2 emissions. Therefore, the clean configuration is the optimum configuration during a holding circuit, and the flight crew should only consider the selection of Conf 1 when on a holding pattern or when there is a speed limitation. And secondly, the speed. In a clean configuration, the flight crew should fly at the managed speed, that is, green dot speed, as it is a good approximation of the maximum endurance speed. That was about the holding. Let's now focus on the approach phase. The two variables that the flight crew can modify for fuel saving during approach are the deceleration and, as it was also the case for holding, the flap configuration. When conditions and ATC permit, a decelerated approach reduces fuel consumption. If the approach type does not enable to fly a decelerated approach, the flight crew should only fly an early stabilized approach. Again, the flight crew should optimize the configuration management with landing gear and flaps extended only when necessary. As explained in the Wind video episode number 7, dedicated to the descent phase, Airbus is developing different initiatives to optimize the descent and approach. Therefore, for a continuous descent approach, the deceleration level off is removed. This fact will minimize the time the aircraft stays at a non-optimum altitude and therefore reduce the fuel consumptions and CO2 emissions. When preparing the landing, and where conditions enable its use, landing with flaps in Conf 3 will allow fuel savings because the aircraft is more aerodynamically efficient than in Conf 4. However, landing in Conf 3 means more deceleration energy to stop the aircraft, and that can result in longer landing distances. As you can see in the table, the reduction in CO2 can go up to almost 70 kilos for an A350. Next, the use of either reverse on landing instead of full reverse. This will reduce fuel consumption and may be positive for the engine. But again, this also may increase the landing distance, and therefore either reverse can only be used when performance permits, particularly in the case of wet runway conditions. A very important phenomenon to take into account is brake oxidation. It happens when the brake reaches high temperatures many times and a large amount of energy is dissipated by the wheel brakes due to high approach speed, low drag configuration, and the use of idle reverse thrust. This can result in the degradation of the carbon material and to a loss of its strength and possible ruptures. To avoid this and extend the life of the brakes, we recommend the use of auto brake at landing, BTV mode or low, depending on the aircraft family. You should also take care not to override the auto brake to decrease the landing distance, except in the case of emergency. Also, to avoid the brake oxidation, it is better to select the best exit on the runway after landing, looking for a good compromise to limit the energy in the brakes. For example, an exit beyond the wet line. The planned exit taxiway after landing can also have an impact on the selection of the configuration for the landing versus the taxi time saved. For instance, you should avoid making a U-turn at the end of the runway and backtrack the runway to save fuel. To summarize, and as you can see in the table, the best combination for landing when the landing performance permits is to use the flaps in CON3 together with idle reverse and the auto brake. And don't forget that the right balance between performance and fuel consumption should be found during the selection of the landing configuration. As for the lateral guidance, Airbus aircrafts include equipment that provide a high navigation accuracy. Some specific procedures, such as the RMPAR, can be developed and applied, and they enable the reduction of the distance flow during takeoff or approach. An RMP approach procedure can reduce up to 945 kilograms of CO2 or 300 kilograms of fuel per approach, compared with the standard published instrument approach. In the same way, visual approaches can also be considered, as a per instrument approach path do not always offer the most direct route to the runway. To conclude, during this video, we have seen that fuel savings and reduction of CO2 emissions are possible during holding and approach phases. To obtain the best aircraft efficiency, you should keep clean configuration for holding, hold at green dot speed, prefer decelerated approach, when possible, select CON3 with rev idle and auto brake in low or VTB function depending on the aircraft family, and finally, consider the RMPAR or visual approach. Thank you for watching this episode of the Wind Sustainability Series. Stay tuned for more on how to reduce fuel consumption and CO2 emissions during the other phases of the flight.